Okay, welcome to another fun adventure in math. In this lecture, we are going to take a look specifically at factoring. Now, for those of you that are watching in a college algebra course, factoring is considered to be a prerequisite for the course. So what we're actually going to do in this video is touch base on refreshing what it means to factor polynomials, not extreme detail with it. The first thing that you always need to remember with factoring is that you want to look and see if you have a GCF. Now remember, GCF means greatest common factor. So you want to look and see if by chance you can pull that out. Because remember, taking something big, hairy, and scary down to something more manageable makes everybody's life a little bit easier. So looking for those greatest common factors is the easiest way to make your polynomial seem less scary. Now the other thing you have to do is you have to be able to determine what type of factoring you are going to have to be able to do depending on the formulas or the polynomial that you have been given. So there are different methods of factoring, and we're going to touch base on all those different methods here. The first method is looking at what are called two-term polynomials. So when you're looking at the polynomials you have, our two-term polynomials have three different types. The first would be a difference of squares. So the difference of squares says if you're given a squared minus b squared, then you can automatically state that that is going to factor into a plus b times a minus b. Okay, and that is called a difference of squares. Squares meaning your two terms have an exponent of 2, difference meaning your terms are being subtracted. Then we have a sum or difference of cubes. So it's just like the difference of squares, but instead of squares we have cubes. And then we have a sum equation and a difference equation. So the sum equation is very simple. You're going to have a plus b, and then you're multiplying that by a squared minus ab plus b squared. The way I like to remember it is this. If I started with a plus, then the signs of my factors have to go plus, minus, plus. Okay? Now if you start with a negative, so a minus b, then the signs of your factors are going to go minus, plus, plus. Okay? So again, if you look, these are almost identical. The only thing that changes are your signs. Now the last two-term type is what's called square of binomials. So what that means is that you have a perfect trinomial sitting here, which means it will factor down into the same identical binomial twice. So we call that the square of binomials, because why write it twice if we only need to write it once? So if my trinomial is both positive, then my binomial is positive. If my trinomial is minus positive, meaning opposite signs, then my binomial has the opposite sign. It's both negative. Okay? So those are two terms. Now the other thing that we have is we have three terms. Three terms means that we have trinomials that we're working with, and there are quite a few different ways that you can approach these. One way is to approach it by means of the FOIL method. So remember, FOIL stands for first, outer, inner, last. And essentially what it says is that you are going to go directly from your trinomial down into your factors by taking the idea that your first term or your square term is going to split into variable, and then in order to create the others, you need to keep in mind that your last term, or the C term, you need factors of that term that when added together will give you the middle term, or the B term. Okay. The more surefire way is by using what I like to call the bottoms-up method. In other words, it's actually called the AC method, but I like to call it bottoms-up just for fun. What it essentially says is that first you need to make sure you're written in standard form. Then you need to check for any GCFs and pull them out. The form itself, or the method itself, says you are going to take your numbers. So we're going to take the term for your A term and multiply that by the C term. You are then going to find all of your factors of that new term, i.e. the value you get when you multiply A and C together. You're going to rewrite into the following form: x plus factor, and those factors there have to add together to give you the B term. Now, once you rewrite it into your new form, you need to divide your factor by your A term and then reduce your fractions. Bottoms up comes from your last step, where anything left in the denominator of your fraction will bottoms up and become the coefficient of the x value, or the variable. So that is 3 terms. The very last type we have is 4-term factoring. 4-term factoring can only be done one way, and that is the grouping way. Grouping says you're going to look at your first 2 terms and you are going to pull out a GCF of only those 2 terms. You are then going to look at the back 2 terms, or your last 2 terms, and your goal is to pull out a GCF that causes the factor left behind to be the same on both the front term and the back term. Okay. So now that we got all of the crazy definitions out of the way, what I'm just going to do is walk through a bunch of different types of examples, and we're going to discuss which method you should use to solve this example, and then look at how to actually solve it. So in this first term, notice I have 12x squared plus 28x minus 24. So all methods start by looking at your problem and identifying if you have a GCF that you can pull out. Well, in this case you do. Your GCF here is going to be 4. Since I've identified what it is, it means I actually need to pull it out. So I'm going to pull that 4 out, and I need to look at what's left. So when I pull 4 out of 12, that's going to leave me with a 3x squared behind. Pulling a 4 out of 28 leaves me with a plus 7x. And then pulling 4 out of 24 leaves me with a negative 6. Okay. Now, what I am going to do is I am going to look at this 4 and I'm just going to ignore it. Okay, so it's kind of like your child who you are so tired of that you send to their toy room and lock them there for the rest of the day. However, don't forget that he's in that toy room. You do need to open the door and let him out at some point, and so what you'll notice is we will bring that 4 out of its toy room and back into play at the very end of the problem. Instead, the only thing that we are going to care about for the moment is going to be my new reduced trinomial. Okay. Now with this trinomial, because my A term is greater my A term here is greater than 1, we are going to use bottoms up. Okay. So that's the method that I would suggest using. Now obviously, could you approach it in other ways? Sure. I would suggest using the bottoms up method because this A term here is greater than 1, and this method is just going to make it a lot faster in order to get into your factors. So the bottoms up method says the first thing you need to do is you need to multiply A times C together. So my A is going to be 3. So this is 3. My c is negative 6. And when I multiply those together, I get a negative 18. The second step says that I need to list all my factors of 18. So I know that I have 1 and 18, I have 2 and 9, I have 3 and 6. I need to know which one of these factors, when added together, will give me a 7. And I need to keep in mind that these factors are negative. One of them needs to be a negative. So if I'm looking at this, 1 and 18, no matter how we shake it, is not going to work. So you could cross that kind of off your list. Now if we look at 2 and 9, I need to have a positive 7. So if I make 2 negative and my 9 positive, notice I get 7 as a result. So this is going to be the pair that I want to use, which means 3 and 6 don't work. Once you identify your factor pair, you need to set it up into your form. So you want to use the form x plus or minus, and then it is your factor divided by your a term. And so you want to set that up for both. So when we look at this, my factors are negative 2 and positive 9. So I am actually going to have x, and then I'm going to have minus 2 over, and my a term is still a 3. So this is 2 over 3. And then I need to do the other side. So here this is going to be x. My 9 is positive, so it's plus 9 over 3. After you put it into this form, you need to reduce the fractions completely. So when I look at 2 over 3, there's nothing I can do. That already is reduced as far as it can go. So I have x minus 2 over 3. However, 9 over 3 reduces. 3 goes into 9 very nicely. It goes in 3 times. Therefore, I am left with x plus 3. Once you reduce your fractions, this is the bottoms up step. So the bottoms up step, okay, this step says you're going to take whatever denominators are left, so in this case it would be this 3, and you are going to bottoms up and pair it with the coefficient of whatever variable you had. So bottoms up says this becomes a 3x minus 2, and we still have x plus 3. Now remember, just a little while ago I talked about locking up that 4 into his toy room. Well, now's the time where we need to let him out, and you need to remember that you started by pulling that GCF of 4 out of your problem. Thus this is your factored form. So let's go ahead and look at another one. Here I have 24x to the 12th minus 375. Well, at this point, it's a little difficult to figure out which type of factoring we're going to use. However, we do know one thing's for sure. We know that it is a two-term factor. So we have 3 choices. This can either be difference of squares, or it can be sum or difference of cubes. We need to find out which, and the way we do that is by looking to see first if we have a GCF. And in this case, we do. My greatest common factor here is going to be 3. So I need to pull that 3 out so I can determine which type of factoring I'm going to perform. So pulling that 3 out is going to leave me with 8x to the 12th minus 125. I still am not completely sure which I have to work with, so I have to look specifically at my numbers. And what do I know about 8? Well, I know that 8 is a perfect cube. Since 8 is a perfect cube, that means what I'm actually dealing with here is going to be a difference of cubes. Now that I know exactly what it is I'm working with, I know which formula I have to use. So I'm going to be using my difference of cubes formula, which says that I have A cubed minus B cubed is going to equal A minus B times A squared plus AB plus B squared. So to do this problem is very simple. I have to be able to identify A and B. So let's go ahead and look at that. First, let's see if we can identify what A should be. A is the first term, so it means we are looking at 8x to the 12th. So I have to be able to turn this into something that is cubed. Well, I already know that 8 was a perfect cube, and so that would reduce to being 2. 2 cubed is 8. So I need to look at my variable here. So the way I determine what it has to be is I know it's going to be an x. But to determine what this exponent is, says that I have to take what my current exponent was and divide it by what I wanted on the outside. Well, 12 divided by 3 is going to give me 4. So this is really going to be 2x to the 4th and cubed it. And notice I have my first cubed term. I now need to look at my b term. So b is going to be 125. Well, 125 is also a perfect cube. It's a perfect cube using 5 cubed. So these right here are a cubed and b cubed. What this means is that my a is actually 2x to the 4th and my b is going to be 5. Now I'm going to use this information right here, and I'm simply going to plug into the formula. So the formula says I'm going to do a minus b. So this is going to be 2x to the 4th minus 5. And I'm going to multiply that by a squared. So this is 2x to the 4th squared plus a times b. So 5 times my 2x to the 4th plus b squared. So 5 squared. One of the things that you have to remember about all factoring is that you have to do the math. Meaning you cannot leave it like this, you have to simplify it down. So I know my first term is still going to be 2x to the 4th minus 5. My next term here, I have to square the 2 and square x to the 4th. So 2 squared is 4. X to the 4th squared is the same as x to the 4 times 2, which is 8. I'm then going to add this to 10x to the 4th, and I'm going to add this to 25. Now the last thing we need to remember is when we started all of this, we had a GCF that we sent to their toy room. And so now it's time to pull it back out, which means you plop it down in front, and thus you have finished your problem. And this right here would be the factored form of what we started with. This next one we're going to look at is 3x to the 4th minus 48. So again, not real clear or 100% sure exactly which factoring we're going to follow, but we do know one thing is for sure. We can pull out a greatest common factor of 3, thus reducing our problem. So 3 is on the outside, making this x to the 4th minus 16. If you look at 16, what do we know? Well, here we know that 16 is a perfect square, meaning that this is actually going to be the difference of squares. So the difference of squares formula very simply says if I have a squared minus b squared, then that is going to give me a plus b times a minus b. So again, we need to find the a and the b terms. So my a squared is going to come from x to the 4th. When we look at that, again, just like with our cube, we have to turn x to the 4th into something squared. So this is going to be x to the 4 divided by 2, which is going to simply be put as x squared squared, making my a term x squared. When we look at the b squared part, b squared is coming from 16. So if we turn that into something squared, it's simply 4. Therefore, my b is 4. So the first thing I gotta do is I gotta plug it into my formula. So this is going to be x squared plus 4 times x squared minus 4. Now a lot of students would stop here. However, you would be wrong. And the reason for that is because if you take a look at the second right here, what do we know? Well, we know that 4 is a perfect square, which means we have a second difference of squares to work with. Remember the good old rule that you need to do the math. So sometimes when we are dealing with difference of squares, you will have more than one rolled up into one problem. So we have to do everything all over again. In this case, my a squared term here is going to come from x squared. Thus, my a is going to be x. My b squared term comes from 4. So this means that my b is going to be 2. And why is that? Because 2 squared is 4. So what do we already have? Well, we already have x squared plus 4, which does not reduce any further. And now we need to add on to it our new ones. So we're going to still have a plus b, so x plus 2, and a minus b, x minus 2. Now let's also not forget our good old greatest common factor. So we need to remember at the very end that you still had to include him through the problem. Thus, this is the true final factored form. Okay. The next one that we're going to look at has 4 terms. So right off the bat, we automatically know that this is a grouping problem. So a grouping problem says I'm going to have to group the first 2 terms and the last 2 terms, and my hope is that I end up with the same factor. So I have m cubed plus 6m squared minus 2m minus 12. So I want to group together my first 2 terms. So I'm going to look purely at the first 2 and nothing else. And what I want to do is I want to find the greatest common factor of these terms. Okay. So I have an m cubed and I have a 6m squared. So in this case, my greatest common factor here is going to be m squared. So I'm going to pull that out. So my first term, I pull out my m squared, and what's left behind is an m plus 6. Once you get that finished, now you need to look at the second. So once we did that, now we can look at the second. And again, I want to find a greatest common factor of these terms. And I'm hoping that when I pull that common factor out, I'm left with m plus 6 as my factor. So that is my goal. So when I'm looking for a greatest common factor here, I'm looking at what is common between negative 2m and negative 12. That will give me a positive 6, or positive in my factor here, which means the first thing I know I need to pull out is a negative. Now what's common between 2 and 12 is going to be 2. So my hope is that if I pull out a negative 2, that I get m plus 6 on the inside. So this is going to give me negative 2 on the outside, leaves me with an m. My sign here is going to change to positive, and 12 divided by 2 is 6. So notice my 2 factors are exactly the same, which means I did do things correctly. And so at this point, all I need to do now is I need to rewrite or write out my equation. So I have m squared times m plus 6 minus 2 times m plus 6. So this is the way it works. You are going to group together the outside terms first. So this is going to be m squared minus 2. And then you are just simply going to write your factor down. So then this is going to be times m plus 6. Now notice I only wrote it once, and this ends up being your reduced factor. Do not write m plus 6 twice, because essentially what you did is we had pulled that out as a GCF. So again, what I always like to say is you're going to write your outer 2 terms together and then rewrite your factor only once. Okay. Alright, this one is going to be very similar to the other ones we did, only in this case, when we pull out a GCF, it's not just a number. So here, if we look at a greatest common factor, we have 18, 51, and 15. So your greatest common factor there is going to be a 3, but notice I also have x cubed, x squared, and x, which means not only am I going to pull a 3 out, but I'm going to pull an x out. Okay. When I do that, this is how it changes. I get a 3x on the outside, pull a 3 out of 18, and that leaves me with 6 behind. pull an x out of x cubed, and that gives me x squared. Repeat the process, pull a 3 out, and that is going to leave me with a 17. Pull an x out, and that leaves me with x. For the last one, if I pull a 3 out, that leaves me with 5. If I pull an x out, still leaves me with 5. Now, I have 3 terms here, and what do I know? Well, I know that my a is greater than 1, so I'm going to go ahead and use my bottoms up method in order to solve. So here, bottoms up says I have to do a times c. My a term was 6, my c term is 5. A times c gives me 30. I need to find my factors of 30. So those would be 1 and 30, 2 and 15, 3 and 10, 5 and 6. And I need to know which combination of these, when added together, gives me 17. Well, 1 plus 30 doesn't work, but 2 plus 15 is 17, so both of these are positive. Thus, I found my factors. Now I need to take those factors and I need to make x plus or minus your factor over the a term. And so when I do that, I'm going to get x plus 2 over 6 times x plus 15 over 6. I need to reduce. So first we're going to make your factor, then we're going to reduce the fraction. So I need to reduce each fraction. So here this is still an x plus. 2 over 6 is going to reduce very nicely. 2 goes into 6 3 times. So this is going to be 1 over 3. And then on the other one I have x plus, and again 15 over 6 has a common. What's common there is 3. So I'm going to take 3 out of top and bottom, leave me with 5 over 2. Then you are going to bottoms up. And the bottoms up step says whatever is left in the bottom has to become the coefficient to your variable. So again, whatever was left in the bottom becomes the coefficient to the variable. Thus, making these the factors of 3x plus 1 times 2x plus 5. Again, we had a greatest common factor in the beginning. Remember our good old GCF of 3x. And so here we have to put this down out in front. So here, this is going to be our factored terms. Now the very last example that I wanted to go over and do is I wanted to do a quick recall refresher on multiplying binomials together and how that actually works given something other than using just straight numbers. So we have 2x plus y squared times 3x plus 2y squared. So the easiest way to do that again is FOIL. So I've got 2x plus y squared times my 3x minus 2y squared. FOIL says first, outer, inner, last. Okay. So what exactly does first, outer, inner, last mean? Well, first means I'm going to take my first two terms and multiply them together. This makes FOIL. So when I'm talking about my first, I'm talking about 2x times my 3x. Okay, so this would be my first. When I'm talking about outer, I'm talking about my outermost terms. So that would be the 2x and the negative 2y. So I'm going to add this to my outers. So I have that 2x times negative 2y squared. This is the outermost terms. I then have my innermost terms. So inners would be the y squared and the y. So this is plus y squared times my 3x. This is my innermost terms. And then I have my last terms. And so my last terms would be just that. They are the last terms that we have. And so here this would be plus, and I've got y squared times negative 2y squared. Okay? And so this is my last. Once you have figured out all of your terms, then you just simply have to do the math and you're good to go. So 2x times 3x is 2 times 3 is 6. X times x is x squared. I'm going to add that to the next. 2 times 2 is a negative 4. X, y squared can't combine, so it's rewritten. Y squared times a 3x is going to be plus 3xy squared. And then I have y squared and a negative 2y squared, so this is going to be minus 2y to the 4th. The last thing you need to do is you need to combine here in the middle, because this is combining your like terms. So this means I'm going to be left with 6x squared minus xy squared minus 2y to the 4th. And this would be your trinomial. So one thing that you need to remember when we're doing or working with binomials is that not all of them are nice numbers. Some of them are complicated expressions and thus give you answers that incorporate more than just a single variable. Okay? So that's kind of everything that you needed to know in a nutshell. That's your refresher on what some factoring is going to be. So if you have any questions, please make sure that you let me know. Otherwise, remember to have some fun, and I'll see you next time.